Good afternoon, students. Welcome back to chemistry class. Today we are going to study about periodic trends in properties. Periodic trends in properties. As we know, the periodicity means elements with similar properties reappear at certain regular intervals of atomic number in the periodic table. The elements with the similar properties reappear at certain regular intervals of atomic number in the periodic table. Understood? If you observe these two groups elements, first groups and 18th group elements, the first group elements, all the elements in the first group having the similar outer electronic configuration. Hydrogen 1s1, lithium 2s1, sodium 3s1, potassium 4s1, rubidium 5s1, cesium 6s1, francium 7s1. Like that, the group 18 elements, all the elements in the group 18 are zero group elements having the similar outer electronic configuration. Okay, these similar outer electronic configuration is reappear at regular intervals of atomic numbers. Okay, for example, hydrogen to helium first period, okay, first period, hydrogen to helium first period, lithium to neon second period, sodium to argon third period. Okay, if you are observing these between the atomic number between these two elements are the hydrogen and helium, the difference 2, okay, hydrogen 1, helium 2. After the lithium to neon, 8 atomic number increases with the 8, okay, lithium atomic number 3, neon 10, okay, so lithium to neon atomic number increases with the 8, okay, 8. So the after 8 atomic number, after increasing 8, the sodium will form, okay, sodium atomic number 11. Like that, the potassium atomic number 19, but the sodium here 11. Sodium and potassium have the similar properties, but these similar properties will reappear after the interval of 8 atomic number. Okay, sodium atomic number 11 and the potassium 19. Okay, so how much difference here? 8 atomic number increases. Okay, but this is the regular interval. This is called the periodicity of properties. Okay, okay, so first group elements, the valence electronic configuration of the elements showing periodicity of properties, that is, the elements belonging to the same group have the same valence electronic configuration. Thus, we see that in any group, similar valential electronic configuration of the elements reoccur after certain regular intervals of atomic number. Okay. And it is this reoccurrence of similar valential electronic configurations of the elements at certain regular intervals of atomic number which becomes the cause of periodicity of properties. This is we called as the periodicity of properties. Understood? So the periodicity means after regular intervals of time, after regular intervals of atomic number, the similar properties will reappear. Similar properties of elements will reappear. Okay, hydrogen, lithium, sodium, potassium, rubidium, cesium and francium, these all elements have the similar chemical property, physical and chemical properties. Okay, so these similar properties reappear after the certain regular intervals of atomic number. This is called a periodicity. Here, the word periodic. Okay, we're going to study about periodic trends and properties. Okay, here the word periodic means that with the rise of atomic number of the elements in the same period or group, there is a gradual variation in a particular property of the element. Okay, the periodic means the electronic configuration of the elements shows the Periodic variation with increase in atomic number. Okay. The rise of atomic number of the elements in the same period or group, there is a gradual variation in a particular property of the elements. Okay, we studied about that the similar electronic configuration elements in the same group having the similar outer electronic configuration means they are having the similar physical and chemical properties. But some particular properties of the elements are gradual variation. Okay, the rise depend upon the rise the atomic number of elements. Suppose it is the same period or same group. Okay, regular the gradual variation are observing here with rise of atomic number of the elements in the same period or group. Okay, this is the group. Okay, from hydrogen to francium, increase in the atomic number. But here these all elements have the similar electronic configuration. Okay, similar electronic configuration, similar outer electronic configuration means the principal number differ, but the subshells, the electrons, the new electrons enter in the orbitals. Okay, subshells are same here. S orbital. All the elements in the group 1 elements are having the new electrons will enter into the S orbital, S subshell. Okay, principal quantum number shells are differ here with increasing atomic number. Understood? So with increasing atomic number, with rising the atomic number, when we are observing the certain particular properties, here the particular properties gradually vary. What are the particular properties? Okay, what are the particular properties? Now we are going to study. Okay, what are the properties will be vary? First upon atomic radius. Second upon ionic radius. Third, ionization enthalpy or ionization energy. And fourth one, electron affinity or otherwise called as electron gain enthalpy. And finally, electronegativity. These properties are gradual variation. When atomic number increases, these particular properties will be very gradually. Okay, very gradually. Understood? When atomic number increases, rise the atomic number of elements in the same period or group, there is a gradual variation in a particular property of the element. What are the properties? Atomic radius, ionic radius, ionization enthalpy or ionization energy, electron affinity or electron gain enthalpy, and last, electronegativity. There are 5 properties, very important. 5, all the properties are very important. Okay, what do you mean by atomic radius? Atomic radius means the distance between the center of each nucleus and the outermost shell containing the valence electron. The distance. Okay, radius means the distance between the center of the nucleus and the outermost shell containing the valence electron. This is called atomic radius. Ionic radius. What do you mean by ionic radius? Ionic radius means it is defined as the distance from the center of the nucleus of the ion up to which it exerts its influence on the electron cloud of the ion. Okay, distance between the center of the nucleus of the ion up to wherever the electron cloud having that distance. Okay, that is called ionic radius. Atomic radius means distance between the center of the nucleus of the atom. Okay, center of the nucleus of the atom and outermost containing the valence electron. Ionic radius means distance between the nucleus of the ion. Okay, nucleus of the ion and the outermost electron. And what do you mean by ionization enthalpy or ionization energy means? It is defined as the minimum amount of energy required to remove the most loosely bound electron from the valence shell of the isolated neutral gaseous atom in its ground state. Ionization energy means the minimum amount of energy required to remove the most loosely bound electron from the valence shell. Okay, when we are removing the electron from the valence shell, we should give the energy. Okay, that energy we call as the ionization energy. And then electron affinity means it is defined as the amount of energy released when an electron is added to the valence shell of an isolated neutral gaseous atom in its ground state to form an anion. Okay, so ionization energy means the minimum amount of energy required to remove the electron from the valence shell of the atom. Okay, electron affinity means minimum amount of energy released. Okay, when you remove the electron, we should apply the energy, that is called ionization energy. When added the electrons in the valence shell, we get the energy from an atom. Okay, atom release the energy when it added the electron in the valence shell. Understood? And after the last one, electronegativity. What do you mean by electronegativity? It is defined as the relative tendency of an element present in a covalently bonded molecule to attract the shared pair of electron towards itself. Electronegativity means relative tendency of an element present in a covalently bonded molecule to attract the shared pair of electrons towards itself. That is called electronegativity. Understood? These are the periodic properties of the periodic trends and properties of an elements. Okay, today we are going to discuss atomic radius only. Okay, atomic radius only we are going to discuss. So atomic radius of an atom is defined as the distance between the center of its nucleus and the outermost shell containing the valence electron. What do you mean by atomic radius? The distance between the center of each nucleus and the outermost shell containing the valence electron. Okay, so what do you mean by atomic radius? The distance between center of the nucleus. For example, one of the example I am taking, sodium atom, atomic number 11. So electronic configuration 2,8,1. You know, the nucleus is present at the center of the atoms. Electrons revolve around the nucleus in a circular path. Okay, so first orbit, that is called orbit. So the first orbit, how much electrons? 2 electrons. Second orbit, how much electrons? 8 electrons. Third orbit, only 1 electrons. Okay, so here, what do you mean by atomic radius? Atomic radius means the distance between center. This is the center of the nucleus and its outermost shell containing electrons. Okay, distance between center of the nucleus and valence electron. Okay, distance between center of the nucleus and valence electrons. That is called atomic radius. But it is not possible to measure the radius of an isolated atom directly. Okay, not possible to measure the radius of an isolated atom directly. Isolated means it is in free state. Okay, that is called isolated, free state. You know, all atoms does not exist in free state except noble gases. Okay, noble gases only exist in free state. So we can measure the radius of the noble gases. We can measure directly, but in the case of other atoms, does not measure the atomic radius directly. Okay, so Usually, atomic radius is referred to as covalent radius or metallic radius. Okay, atomic radius referred to as covalent radius or metallic radius. What do you mean by covalent radius means? Covalent radius means the distance between two atoms that is covalently bonded. Okay, if two atoms are joined with the covalent bond, that is called the covalent bonded atoms. Okay, metallic bond means the distance and the bond formed between the two metals. Okay, that bond is known as metallic bond. Covalent bond means mutual sharing of pair of electrons between two atoms. Okay, covalent bond formed between the two non-metal. Okay, covalent bond formed between the non-metals. Okay, maybe non-metals, maybe metals and non-metal. That is called a covalent bond. Understood? So here, what do you mean by covalent radius? What do you mean by covalent radius? It is one half of the internuclear distance between two identical atoms linked together by a single covalent bond. What do you mean by covalent radius? One half of the internuclear distance between two identical atoms linked together by a single covalent bonds. Okay, here we are taking two atoms, covalent bonded atoms we are taking here. For example, chlorine. Okay, chlorine and chlorine. The chlorine, it is a non-metal. Okay, so covalent bond formed between the two non-metals only. Okay, two non-metals only. Here, the two covalent bonded atoms, chlorine. This is the chlorine, one of the chlorine atom, and this is the another one chlorine atom. Okay, these two atoms combined by covalent bond. Okay, this bond is known as covalent bond. What do you mean by covalent radius? We cannot measure the atomic radius of an isolated atom. Okay, isolated atom we cannot measure. Okay, so it is we can measure the covalent radius. We can measure the atomic radius, means covalent radius or metallic radius we can measure. Okay. So here how can we measure the covalent radius of two chlorine atoms? That is one half of the internuclear distance. What do you mean by internuclear distance? Internuclear distance means that is the distance between two, the center of the nucleus of two atoms. Okay, center of the nucleus, distance between the center of the nucleus of two atoms. Distance between the center of the nucleus, okay, of two atoms, that is called internuclear distance. Internuclear distance. Okay, so covalent radius means it is the one half of the internuclear distance between two identical atoms linked together by a covalent bond. So one half means this is the distance between internuclear distance between two covalent bonded atoms. Okay, internuclear distance between two covalently bonded atoms, that is this. Okay, so covalent radius means one half. So we can take the half. Okay, half radius, half of the radius of the two covalently bonded atoms, that is called the covalent radius. Understood? This internuclear distance, how we can measure the internuclear distance means internuclear distance can be determined using the X-ray diffraction studies. Okay, internuclear distance of the internuclear distance can be determined using X-ray diffraction studies. X-ray diffraction studies. X-ray diffraction studies. Okay, X-ray diffraction studies only we can measure the internuclear distance between the two atoms. What do you mean by covalent radius? It is the one half of the internuclear distance between two identical atoms linked together by a single covalent bond. For example, the experimental internuclear distance in chlorine molecule is 1.98 Armstrong. The experimental internuclear distance in chlorine molecule is 1.98 Armstrong. The covalent radius of chlorine. How can measure the covalent radius of chlorine? Here 1.98 Armstrong, it is the internuclear distance in the chlorine Cl2 molecule, Cl and Cl molecule. Internuclear distance only 1.98 Armstrong. Okay, how can you measure the covalent radius of the chlorine? So this is here the distance between internuclear distance between chlorine and chlorine. It is equal to R chlorine plus R chlorine. R means a radius of the chlorine. Okay, radius of the chlorine, two chlorine atoms. Radius of the two chlorine atoms, that is, so D into distance between chlorine and chlorine, it is equal to 2 into RCl. Okay, 2 into R plus R, 2 RCl. Okay, so here RCl is equal to, we are taking the RCl, we can measure the, we have to measure the covalent radius. Okay, covalent radius of chlorine atom. Covalent radius of chlorine atom. So we can take the radius of chlorine. Radius of chlorine, it is equal to D, distance of chlorine and chlorine molecule divided by 2. Okay, here the radius of chlorine is equal to, what is the radius of chlorine here? 1.98 Armstrong. Okay, in the distance between chlorine and chlorine, how much measured by experimentally? The two chlorine atoms in the nuclear distance of chlorine and the distance of another chlorine atom, 1.98 divided by 2. Okay, so we get 0.99 Armstrong. The internuclear distance between two different atoms also we can calculate it using one of the formula that is given by Schumacher and Stevenson. Schumacher and Stevenson proposed one of the simplest method to calculate the covalent radius of indivisible atom. Okay. If we know the internuclear distance between the two atoms, we can using this formula, one of the formula, it is given by Schumacher and Stevenson, we can calculate the covalent radius of indivisible atom. What is the formula? D, A and B is equal to RA plus RB minus 0.09 into Ka minus Kb. This is one of the formula, one of the simplest method given by Schumacher and Stevenson. What is the formula? DA and B is equal to RA plus RB minus 0.09 into Ka minus Kb. Okay, here D, A and B, we know that is the internuclear distance between two atoms, A and B, two different atoms. And Ra means covalent radius of one atom and Rb means covalent radius of another one atom. And Ka and Kb are the electronegativities of A and B. Okay, here we are taking the A and B, two different atoms. So Ka and Kb, it is the electronegativities of these two atoms. Okay, always Ka always greater than Kb. The electronegative values that is already predicted by Pauling. Pauling, one of the scientists, he already predicted the electronegativity values of the most electronegative atoms. Most electronegative atoms, that is fluorine, chlorine, bromine, iodine, halogens, nitrogen, that is also the most electronegative atoms. Okay, so Pauling, according to Pauling scale, Pauling, one of the scientists, he already predicted the electronegative values of the most electronegative atoms. Okay, using that values also we can substitute here. The electronegativity of chlorine, that is 3.3. The electronegative value of chlorine is 3 and the electronegative value of hydrogen is 2.1. Okay, these are the two different values of electronegativity. Okay, so we are going to calculate the covalent radius of hydrogen atom. Covalent radius of hydrogen. Using the internuclear distance between hydrogen and chlorine. Okay, these two atoms are different. So, using the internuclear distance between the two different atoms, already experimentally they proved that hydrogen and chlorine, internuclear distance between hydrogen and chlorine already predicted, that is 1.28 Armstrong. 1.28 Armstrong, that is the internuclear distance between hydrogen and chlorine. DAB value, that is 1.28 Armstrong. Okay, so here what is the given value here? You see here this formula D, A and B. D, A and B values 1.28. That is internuclear distance between hydrogen and chlorine. Experimentally they proved that. And RA means covalent radius of hydrogen atom. Covalent radius of hydrogen atom, Ra, and Rb means covalent radius of chlorine atom. Okay, covalent radius of hydrogen and covalent radius of chlorine. Covalent radius of chlorine, we calculated, that is 0.99 Armstrong. 0.99 Armstrong. Okay, so we have to calculate the covalent radius of hydrogen atom. We have to calculate. We are going to calculate now. What is the formula we are using here? DHCl is equal to RH plus RCl minus 0.09 into chi of chlorine minus chi of hydrogen. Why we are writing chi of chlorine first? Because the electronegative value of chlorine will be high. That is 3. Okay, hydrogen only 2.1. So, chlorine is the highest value. So, we can take the chi of chlorine minus chi of hydrogen. Okay, so DHCl values already we know 1.28 is equal to RH, radius of hydrogen, we have to calculate, plus RCl value 0.99 minus 0.09 into the electronegative value of chlorine, chi Cl, that is 3 minus electronegative value of hydrogen 2.1. Okay, so 1.28 is equal to RH plus 0.99 minus 0.09 into 3 minus 2.1, we get 0.9. Okay, so next 1.28 is equal to RH plus 0.99 minus, by multiplying 0.09 into 0.9, we get 0.081. Okay, so here we have to subtract these two values. So 1.28 is equal to RH plus, we subtract these two values, 0.99 minus 0.081, we get 0.909. Understood? So we have what is the value we have to calculate? Radius of hydrogen, covalent radius of hydrogen we have to calculate. So we can take here RH It is equal to, when this value will come here, 1.28 minus 0.909. Okay, when subtract these two values, we get 0.371 Armstrong. Okay, students, from this formula, we get the covalent radius of the hydrogen atom. What do you mean by covalent radius? Covalent radius means 1/2 of the internuclear distance between two identical atoms linked together by a single covalent bond. So, using this covalent radius definition, we calculated the covalent radius of chlorine atom. We calculated using the chlorine molecule radius, that is 1.98. We get the covalent radius of chlorine, single chlorine atom we get. Okay, another one formula, internuclear distance of the individual atom also we can be calculated using this formula. This is one of the formula given by Schumacher and Stevenson. That is the formula distance of the two atoms, that is A and B. We are using this formula RA plus RB, radius of atom A and radius of atom B minus 0.09 into chi A minus chi B. Okay, here we are taking hydrogen and chlorine. For A, hydrogen, and B, for B, chlorine we taken. Okay, so experimentally they proved that the internuclear distance of the hydrogen and chlorine, that is 1.28, and radius of chlorine we have to calculate, and radius of hydrogen we have to calculate. Radius of chlorine already we calculated, that is 0.99 minus this is 0.09. This is the formula. And electronegative chi of chlorine and chi of hydrogen means electronegative values. Okay, there is for chlorine 3 minus hydrogen 2.1. Okay, by substituting these values we get the covalent radius of hydrogen atom, that is 0.371 Armstrong. Understood? I hope all of you understood. Then we are going to study about the metallic radius. Metallic radius means it is defined as the 1/2 of the distance between two adjacent metal atoms in the closely packed metallic crystal lattice. Okay, it is defined as the 1/2 of the metallic radius. It is defined as the 1/2 of the distance between two adjacent metal atoms in the closely packed metallic crystal lattice. The metallic radius means 1/2 of the distance between two adjacent metal atoms in the closely packed metallic crystal lattice. Understood? So, what do you mean by covalent radius? Covalent radius means 1/2 of the internuclear distance between two identical atoms linked by single covalent bond. So, atomic radius means distance between center of the nucleus and outermost valence shell electron. But we cannot measure the radius of the isolated atom directly. So, we can be calculated using covalent radius and metallic radius. Okay, covalent radius already we studied about covalent radius. Now we are going to study about the metallic radius. It is defined as the 1/2 of the distance between two adjacent metal atoms is in the closely packed metallic crystal lattice. Okay, here we are taking closely packed metallic crystal lattice means This is the metallic crystal lattice. The crystals are arranged in closely packed. Okay, closely packed. That this is the crystal lattice structure. Okay, for example, we are taking the distance between two adjacent copper atoms. We are taking, this is the copper metal lattice. So we are taking here, this is what is metallic radius means the distance between the adjacent copper atoms. Okay, distance between the two adjacent copper atoms, that is the metallic radius. Okay, so distance between the two adjacent copper atoms, experimentally they proved that is 2.56 Armstrong. Okay, experimentally proved by X-ray diffraction techniques. They predicted the distance between the two adjacent copper atoms, that is 2.56 Armstrong. Using this value, we can be calculated the metallic radius of single copper metal. Okay, single copper metal we can be calculated using this two adjacent radius of two adjacent copper atom value. Okay, so 2.56, that is the radius of distance between the adjacent copper atoms. And what is the radius of copper atom? That is 2.56 divided by 2. So we get 1.28 Armstrong. So the metallic radius can be calculated using the unit cell length of the metallic crystal. Unit cell length of the metallic crystal, we can be calculated the metallic radius. Okay, you will study a detailed calculation procedure in your 12th standard solid state unit. 12th standard, when you are coming the 12th standard, we will study clearly about the metallic unit cell. About that we can be study clearly. Okay, students, today your assignment, today 3 assignments, 3 simple questions I will give today. Question number 1, what is atomic radius? Question number 2, what is covalent radius? Question number 3, how can you calculate the covalent radius of chlorine atom? How can you calculate the covalent radius of chlorine atom? Okay, I will mark the question. If you having the book, take your book now. Students, take your book now. Page number 79. What do you mean by atomic radius? First question. The atomic radius heading 3.5.1. Atomic radius of an atom is defined as the distance between the center of its nucleus and the outermost shell containing the valence electron. Atomic radius of an atom defined as the distance between the center of its nucleus and the outermost shell containing the valence electron. Up to here you mark. And second question, the covalent radius. What is covalent radius? It is 1/2 of the internuclear distance. It is 1/2 of the internuclear distance between two identical atoms linked together by a single covalent bond. Up to here you mark. It is 1/2 of the internuclear distance between two identical atoms linked together by a single covalent bond. This is the second question. And what is the third question? How to calculate the internuclear distance, covalent radius of chlorine. How to calculate the covalent radius of chlorine? There is here example. Okay, the experimental internuclear distance in chlorine molecule is 1.98 Armstrong, The covalent radius of chlorine is calculated as below. DCl to ClCl is equal to RCl plus RCl. DCl Cl means that is internuclear distance of the chlorine molecule. Okay, there is the value given, that is 1.98 Armstrong. Understood? Is equal to 2RCl. 2RCl means RCl plus RCl, that is 2RCl. Okay, so we have to calculate the covalent radius of chlorine, single chlorine atom. We have to calculate. So we can take as the RCl here. RCl is equal to DCl minus Cl by DCl and Cl by 2. Okay, the internuclear distance of chlorine and chlorine, that is 1.98. They experimentally using X-ray diffraction studies, they experimentally determined this value of internuclear distance between the chlorine molecule. So that is 1.98 by 2 is equal to 0.99 Armstrong. Up to here, you have to mark. Understood? 3 questions, very, very important. Study well. Students, everyday portions you should study every day. Okay, don't take it easy. You study well. And every day you should study and write and send me through my WhatsApp. Okay.